So the first questions that's come into our mind: what is recommendation system, and why we need to learn this system, why it is important in the today's world. So let's see through a practical example. Now I am going to the page of YouTube, Amazon's and Netflix, and I will live showing how these recommendation systems actually practically useful in our daily life. Okay, let's see it first. Now I am on my YouTube channel page. So the based on my watch history, the YouTube has recommended some videos here. Just see it. So based on my watch history, the YouTube has recommended that based on this video, that the one of our video in probabilistic and statistics chapter. This is the first introduction to probability and statistics. Okay. Based on this video, they have recommended it. So operation research assignment theory from the one of channel that is related to this content. Okay, and the another video of my channels also, the advantage and limitations of the density clustering and how to initialize the k-means plus plus. So this is our related content. So what is dynamic model, what is artificial intelligence and machine learning. So these kind of recommendations they have given us based on my watch history. So let's see another thing. Let's see. So what is the next video? It's from another channel, how to learn OpenCV. That's also related from my content. And how to ensembles models, how to learn ensembles models, tutorials on the explaining machine learning. These are the contents for related to this video. Now the questions, how YouTube know that these are the related content to my watch history. This is the related content to this video according to my watch history. How to know these kind of things? What is the mathematics behind it? So let's see. So this is the from the just YouTube, the use the recommendation system like that. They have simply they have recommended something. So if you just see your YouTube channel or something, your YouTube history based on the based on your saying history, okay, they have recommended after end of some video, they have automatically recommended how to what kind of related content you are interested to see. Okay, so how these things actually happen. So what is the behind this? What is the algorithm behind these recommendation systems? We'll see this thing. So now let's to another page that I'm going from the Amazon India website. I am now Amazon India website homepage. Okay, just I'm picking here one product, that is the Corsair a RAM. I'm 8 GB RAM. I'm product just they am now just go to the below of this page. So this is a this is the computer gadgets that I'm recently I have bought this item. So now bought from related to this content, they have suggest me these are the some recommended product, means this is a sponsored product actually, as they have showing some recommendations from the sponsored product. Means sponsored means the company they have given the ad and they have paying the some money to Amazon to showing this ad. Okay, this is the sponsored product related to my related to this item. and also and they have given some also they have given some recommendations. Customer who viewed this item also bought, also viewed this, and they also viewed this. Means according to the viewer history, those customer who are already viewed this item, they also views this item. They also views these items. Now how the Amazons are recommended these are the related content to this item. Okay, those customers who are buying this item, they also may buy this kind of item. Just see this is also a computer gadget type of thing, computer RAM related thing. So how these things are happening, what is the algorithm behind behind this technique, we'll see these things. Okay, now let's go to the another page. I am now going to the Netflix page. Now see the applications of it. In Netflix page, just see it. This is on my friend's account. Actually, it's not mine. So I'm just use it to showing the. This is the one list that they are giving using the watch history on that account. They have suggest us. They have suggested these are the I mostly like, I may like, that is Macro Polo, that is WeChat, Zeros movie. Based on our watch history, they had recommended. And also say they continue watching for this my friend's name. So they have all the instantable make some kind of recommendations they also give us. And they also recommended us what is the most trading show on Netflix India. Okay, they have given some recommendations on it. See it. These are the mainly applications of the recommendation system. And in productions, if you work on a production based company, such like as e-commerce company, like such kind of where to increase the sales, this is very important. Okay, the recommended to some things related on that. So sometimes you also see some things, suppose you are searching something related on your choice. So after some time you got see some suggestions from your Facebook account or YouTube account, they got some ad related from your search. So how will give such kind of thing? How will know that you are interested to this kind of items? Okay, how will know? Actually, the behind this technique, they are have worked some algorithms. So these algorithms are actually called the recommender algorithm. Okay, so recommender algorithms. Now let's see how to formulate this recommendation system by simply using the simple mathematics. Okay, let's see it. I think you have understand how these recommendation systems are useful in our today's world, how these things are useful. Okay, now let's see what is the mathematics behind this recommender system in this series. So we have seen here, just we have seen from YouTube, we have seen how much application it is from Amazon. We have seen these things, how much application it is from the Netflix. Also, there are very huge amount of applications. Okay, I'm not going to discuss every applications. So just my motto is to understand how these recommendations systems actually work. Okay, now so we have seen here there have two quantities. First one is user, and based on the user experience, based on the user history, based on the some parameter of that users, they have to suggest some item. Okay, so they have two quantities useful. We have to need two quantities. First one is users. As depends on our situations. If you consider the YouTube, user is we are the user of YouTube, Amazon's, Netflix, we are the users of it. Okay, and the items corresponding to the item that we are interested to recommend it to that user item. Suppose let's take this item is AJ. Okay, so this item may be a video, maybe a movie. Suppose if we are consider the YouTube, this item is a video. If we consider the Amazon, this item is a product. Sorry, it's a product. If we consider the Netflix, this item may be a movie. Okay, so it depends on the domain to domain. What is our actual domain? So these kind of items we have to recommend it to these users based on the some parameters of that user. Okay, that's the past job. That is the past task that we have to do. This is the task that we have to do. So the first thing that task is, so for a user UI, based on some item, based on some history, means based on some items of that user, interest of that some users, based on interest, based on the interest of some items. Item could be let I1, let I3, let I9, let it may be I11. Based on these items, suppose let's take the I'm talking about YouTube, which conditions of the YouTube. Let's take the users have seen this interest to see these videos, means I1 video, I3 video, I9 video, I11 video. Now our task is we have to recommend it some video ij for that users that is based on the value of this item, that is based on the value of this item. Based on this item we have to recommend it. This thing, it will be better if we make the sign this side. We have to recommend it this item to this user. Recommend, we have to recommend it this item, okay, to this based on this is the task that we are interested to doing. We are interested, we have to do these tasks on this chapter. Okay, now let's see. So the task that first, the task is we have to recommend it, recommends relevant item to a user based on some historical data, means based on it maybe a watch history of his video, what kind of video they have watched, what kind of product they have bought, what kind of movies they have seen. So based on this historical data we have to recommend it some items to that user. That's the job that we have to do based on the historical data. We have to do this job. That's the thing that always you have to remember in this. First task is we have to recommend it the relevant item, okay, the relevant item and as well the historical data. That's the two main thing here important. Okay, now let's see how to formulate mathematically this system that we are discussed. How to formulate. So let's see the formulations behind it. What is the mathematics behind this system? Okay, let's see the mathematics behind the system. I think it is better word. I am using the formulation. Formulations. What is the form? How to formulate? So now first, let's see how to formulate the data sets for the user. So in classifications, we have seen. Just if you remember, in classifications, we have seen the data set is look like this xi, and they have corresponding output of this yi. This kind of data we have seen in classifications and regression. Classifications or regression we have seen, and the data are look like only xi. We have seen these data are useful in unsupervised model in clustering technique. These are the type data of the unclustering technique. Now what will be the data? What will be the data in this recommendation system? What will be look like this data? So let's see. So here suppose first we have to let in our system we have n users. In our system we have n users and corresponding age users. So we have n items. These are the in our system we have n users and corresponding age users. We have m items. So let's see. So the related data sets is the data set is A. Okay. So now the data sets will be look like this. Okay. Now the age row is responsible for here age user. Here age row is responsible for age user. U1, U2, u3 up to we have how much users? We have n users. This is responsible for n users. Okay. Now h, this is responsible for the same color. H user. Okay. Okay, H row is now responsible for H user. Now let's see H column. Now H column will be responsible for, now H column, now it will be responsible for H items. So the item is M item for H users, I1, I2, I3. It is for IM. We have M item for H users. So this look like that. This is look like this. So this is the look like this. So the size of the matrix here. See, the size of the matrix is here n row and corresponding m column. This is the size of our data sets for n users and corresponding m items. Now, what will be the value of the H cell for this matrix? That's the questions. What will be the value of H cell? What will be the value of, suppose let's take, I am talking about this common. I'm talking about this column. Suppose let's take, this is the column for ij column, ij. Okay, this is the column for ij, and this is the column for ui, means user I. This is the column responsible for ui, user I. This is column. This is the user I, and this is the corresponding item j. Now let's take this, the column, this the cell value for this is aij. aij. This is for user I, and for user I and item j. This value is, suppose let's take this aij. Now the question is what will be the value? Now the question is what will be the value of this aij? What will be the value of this aij? This is the question. So what will be the value of this aij? So the value of the aij will depend on situation to situation. So suppose let's take, we are considering it a Netflix problem. Netflix. So now for Netflix, this value aij, this value will be a rating that has been given by the user for this item ij. This value will be a rating. This value is a rating given by the user ui on the item ij. It may be 1 to 5, it may be good, very good, average, low, like that. Means simple rating, means it will be sometimes some this type of rating. Okay, its notation will be depends on our applications. These are the rating that has been given by the user I to the item uj. Now let another, suppose let's this, we apply this data, we have collected this data from the YouTube. Okay, so then this value aij for YouTube, this a value watch history, means the user ui, how much time he or she has watched, how much time, means watch time. Watch time. Watch time. So suppose let's take this watch time is normalized to 1 to 100. How much percentage he has watched? It is if this video is 10 minutes, means If he was it for 2.30 minutes, 2.30 seconds, then according to this value, then we have to convert it. How much time the users has watched this item, this video item is here video, this video. So this is the watch time sample. This is the numerical quantity. This is a discrete quantity. Okay. Now, if we apply this system on the Amazon, if we apply this, if we build this, it's data set from Amazon, this value for this Amazon product, this value now will be the product in based on the product history. Okay, how many times the product, or you can call how much rating we have given for a product. So rating for this product. Or search history. Are you search this item on your Amazon product page or not, or Amazon homepage or not, or it may be search history. Search history, this kind of, okay, these are the rating of the product. Search history means they have various parameters, and this depends on the use means system to system, user to user, situation to situation. So there are various kind of parameters to build these metrics. In general, it's this type of matrix. I think you got the idea how these data sets have been built actually. Okay, so but the questions is, so sir, in YouTube or in Amazon or in Netflix, there are very billion of users and million of products. In you will see, if you see these things, we have it's common matter. We have a millions of millions of means in general billions of users. If you consider the YouTube, in a YouTube, it's a billions of users. And also the item is millions of items, if you Amazon, or billions of item in video, billions of video in YouTube. So it's the size of the matrix could be very large. So how to handle this matrix, that's the question. Let's see. So the millions of products, so the size of the matrix is very large, okay, in such situation. Okay, but the problem is those matrix are very sparse matrix. If you consider here, so if you consider for a user, suppose let's take, we have considered for this user UI. If we consider these users in general they have shown how much video, they have shown 100 video, 500 video, or 1000 video. Okay, they have mostly they have used, but rest of the video not, it's not possible for a single user. But for a single user, how much movie they have seen? They have shown 100 movies. Or if has a very much movie lover, then have shown how much movie? 200 movies. And so, but in Netflix they are available a millions of movie. So to rating every movie, it's not possible. So in such situations, the most of the elements takes the 0 or NaN value. Most of the elements takes the NaN, means not a number value. NaN, not a number. If we consider Python or MATLAB, some kind of languages, they are NaN means not a number, or it's not applicable. It's not applicable. In such scenario, or 0 means in such scenario, this matrix is very sparse matrix. Okay, if you, so it's better if you just write these examples. If you write these examples, it's better for us. If you write these examples, so for Netflix, so a users UI may be watched a user may be watched 100 or 200 movies, but in Netflix, there have millions of movies. There have millions of movies. Okay, so it is not possible for a users to complete each movie. In such, in because of these reasons, because of this reason, these are the most cells of this matrix A are empty. Okay, I think you got the idea. And because of these reasons are empty. So the matrix that we have got, the matrix A of rating is very sparse matrix. So the matrix A that we have used to build our data set of ratings is a very sparse matrix. Very sparse matrix. Okay, suppose let's take it's better if we discuss through an example. Suppose let's take the number of users is 1 million. Suppose let's take 1 million. So if you consider the YouTube or Amazon's, it's not a thing. It just I'm taking here, but it's actually not a 1 million. It's a billion of people's are are are, are customer on Amazon's or a users on YouTube. Billions of people's. But let we have taken a small number, some small number. Okay, in millions and items for this is suppose let's take for a system the item is suppose let only have taken here 10,000. Okay, but if you consider YouTube, actually it is not possible for a 10,000 videos only available on YouTube or 10,000 products are available on Amazon. Just I am taking for some system they have only 1 million users and 10,000 products. So in such scenario 1 million means what? 1 million means 10 to the power 6, approximately 10 to the power 6, and it's approximately it's 10,000 means 10 to the power 4. Okay, so if you see the dimension, if you see the size of the matrix here, 10 into m, 10 to the power 6 into 10 to the power 4, that means 10 to the power 10. Okay, so it's approximately equals to 10 billion. 10 billion. Just see, we have taken here some small number. Okay, but in practical life there are a huge amount of n and users and items. So for a small number the size of the matrix is here, size of a size of the matrix is we got over 10 billion. Okay, it's a very large number. So to store such kind of matrix is huge space needed, huge space. So space complexity, we need a huge space complexity. So it is not possible to actually in practical life if you see these things it is not actually possible to store this math. So a very large number. Okay, so so let's see. So this is the size of the matrix that we got. Suppose let just try to understand. For example, suppose let the average I am taking here the average users. Suppose let a average, just consider an average user rates 5 movie or items. Suppose it's possible I'm taking the average cases. Okay, so let a average user average user rate rates 5 movies or items. Let 5 movies or items. Let so in such scenario, how much non-zero, how much non-empty value we got from this matrix? If a user give 5 movies or item, So for each user, five movies, here five, here five, here five. So for each five, means in column we got only non-empty cells. For a users we got only non-empty cells, five quantities, and we have 1 million users. So in such scenario we got the non-empty cells. 5 into 1 million means what? Means 5 million non-empty cells we got here. 9 million non-empty cells we got. Okay, so non-empty cells for the matrix A, but the size of the matrix we use 10 billion, but only we got instead of using 10 million we got only 5 millions non-empty cell. Rest of the cells are empty. So that's the actually waste of our space. That's the rest of the space we have not used. How to resolve this issue? Let's see how to resolve. So the sparsity that we have got here. So this the empty cells, the empty that we have got here, that's called the sparsity. Means sparsity means they have nothing. Okay, that's the actually meaning of the sparsity. So now, what is the sparsity value for this? What is the sparsity value for this matrix? Let's see it. So the sparsity value of the matrix A, it will be here the number of non-empty cells divided by number of cells, total number of cells. So number of non-empty cells divided by total non-empty cells, means total number of cells, these are the sparsity value. Okay, but in numerator this is the small number, so it's about 10 to the power 6. 5 into 10 to the power 6 means I think 1 million I have taken yet. Okay, 5 into 10 to the power 6, and it will be 10 to the power 10. It's approximately equals to 5 into 10 to the power minus 4. So just see these things, how much value this one is, sparsity value. Okay, I think you got the idea. Okay, I think the problem that we have faced to design the formulations, to design our system, I think you got the idea. Okay, this is the main problem that we have to face. Now you can call, sir, why we have to use this, why we have to build this matrix. Our actually main focus is we have to recommend the first, we have to remember always what is our task. Our task is we have to recommend something to a users. So why we have to build this kind of matrix? Why not we have using some classifications algorithms or some regressions algorithms? Why it is not? Actually, at the end of the day, we have to give the product, have to review the, actually have to recommend some product or recommended some movie. So why not? If the classifications output give the output 1, then we recommended some such items. It is give the 0, we will not recommended it. So if we give some, if we use the regression value, if we got some smaller value, then I have not recommended it. If we got some larger values for some threshold larger than the some threshold value, then we have recommended it. But why we have not used it? So let's see these things. So we build the recommender system as a regressions or classifications problem? And the questions that occurs into our mind: can we build? Can you use a recommender system? I mean, sorry, I am using this recommended system as a classifications or regression problem, as a classification or a regression problem. Can we use this thing? Okay, let's see. Can we actually use? So Regression classification means just one thing. Classifications means its output AI, the output of the matrix. This matrix, the output, if the output of that matrix means it is the user is either Boolean type, means it is either yes or no. If this aij is 0, 1 or 0 means Boolean type output or integer type, then we have used classification type of. If we have to use the regressions, if the aij's value are some means watch history that I have taken here, means how much time, this is the numerical type. Okay, rate means watch history, numerical. If ai is from 1 to 100 means watch time. If this thing kind of thing happen, then we can use it. Can we use or not? Let's see. There also have some problems. Let's see how the problem we have to face. So suppose let's take we are a scene in a classifications of regressions problem. The data set, we actually need this type of data sets. We need the data. There are two type of quantities, xi or yi. We need this type of data. If we somehow, if we convert this the whole matrix A into this format, means into this xi and yi, then we can obviously use this recommendation system as regressions or classification problem. But the question is how to convert this matrix to this format. Okay, that's the most challenging part. Let's see. Suppose let's take the data set. Here we have to use the A. These are the data that we have used. The questions that occur, suppose let this is our xi and the corresponding output is this yi. So here in the data, just first see these things. In the data, in the matrix, we need two quantities to represent the matrix A, ui and corresponding ij. Suppose let's take for this matrix, we are interested to build for this matrix. For this matrix, we have to find two quantities. This is for ui, this is for ui, and this quantity is for the item j. Now the question is how we represented this to xi through the ui and ij. How we represented this whole vector into a. So to represent this, it means we have to use the features transformation. We'll see when we will discuss the features transformation chapter. We will see how to convert a text or a numerical quantity to a features vector. We will see these things, but somehow we have to use these things. Okay, but somehow. So we have here, just see these things. We have how much users we have, millions of users and billions of product. In such situations, to convert this ui to a features vector, it's a very hard task actually. So actually we need to compute this as a mathematical problem. We have to convert this such kind of vector formula. We have to, suppose let's take, we have converted this thing, these are the vectors we have to use. But these are these kind of vectors we have to convert somehow. These are the features vector. These are the features vector of the user ui. Okay, and suppose let's take, these are the some features vector of the item ij. These are the features vector of the item ij. If we somehow convert these two features into a vector format, then it is possible of the ij. Okay, and this value, this yi, this value will be aij. If we write, okay, this value aij, if we convert. But the problem is here, but the hard task is there, how to arrive at the features representations to this item UI, and because we have here millions of users, because just if you remember, if you just remember, the millions of billions of users, millions, billions, or millions of user or item. So by simply using this, see so much large data to convert a single features vector, it's totally, because really it is because very hard task. We'll see these things. There are some beautiful mathematical hacks to convert this thing. We will see step by step as time progresses. We will see this thing that the hard task is here, but the main hard task is how to arrive, how to arrive at features representations, how to arrive at for the vector, for the item UI, and for the user UI and the item user. Okay, how to arrive at a features representations. Okay. Since the size of UI and item J is very large number, is a very large number. Okay, how will arrive at the features representations? Okay, so that's the very hard task. That's but anyhow we have to do these jobs. If we doing these jobs, then it is possible to us to convert this recommendation system to by simple classifications on regression and system. Okay, classifications on regression technique. So already we have already seen learn already we have learned some beautiful techniques to to calculate the recommendation or means regressions or classifications problem. We have already learned some techniques, beautiful techniques. So but the main hard challenging task is this: how to convert this a large number to a simple features vector. That's the very really very hard task. Now, okay, now somehow using some beautiful mathematical hacks, we will convert these things as a features vector. Okay, now the next questions that we have to mind. Okay, we have built the data sets, no problem. These are the data sets we have built, no problem. But how we will use to for the recommendations or a classifications problem, we needed the training data sets or a test and a test data sets. But how we will use this whole data sets as a training part and for a test part? That's the next questions. That's the next question that's come into our mind. How to use this? How to find the D-train data and the D-test data? How will find this? So the D-train data we have used here. The D-train data we have used the AIJ, responsible for AIJ, where AIJ is not null. Okay, is not null. Means if there are some value, then we will use this AIJ as a simple training value, not null. Okay, in another language it's for non-empty. Then we can use this thing as training data, and we will use the rest of the empty cells. We have to use the rest of the empty cells, all the cells, all the empty cells or AIJ, that we will use as a test data. Okay, but the questions that the size of the non-empty cells is very low. Just see it in only 10 billion data, 10 billion sizes we got. It here only 5 million non-empty cells, but here test size of the test data is very large instead of train data. But the problem is here, the problem that we have to face here, problem that we have to face here, the size of the training data is very less than the size of the the test data. That's the main problem that we have to face. Okay, as time progresses, we will see how to remove this problem. We'll see these things. So now the next thing. Now also for these matrix representations, we faced the size problem, and for the classifications or regressions problem, also we have faced the features transformations problem. Okay, and the size of the also the size of the retrain and test data set problem. So there also we convert these recommendation systems to another way. So it means another way means I'm talking about in some way that we can easily doing these jobs from using some less amount of computation. How will doing this thing? Let's say, so suppose let's take, we will now the course concept that the mathematicians, the data scientists, engineers are actually built. The concept behind it, matrix competition problem. It is a beautiful problem, really. It is a beautiful problem in the applied mathematics. But so we will see as time progresses. We will see how to use this matrix competitions problem to give the answer of the this recommender system. We'll see. So but now let's see how to use this matrix competition problem to give the recommendations of the item. Let's see. So now can we wish the questions that can we use these recommender systems as a matrix competition problem? Com- Completion. Okay, matrix completion problem means for the sparse matrix, our challenge is we have to complete somehow these non-empty cells, means these empty cells. So this is a sparse matrix. Most of the elements is empty, means some little bit amount I have the data non-empty cells. So the challenge part is here how to compute. Somehow we have to fill up these empty cells based on this non-empty data. Okay, that's the main challenging part here. This problem actually called the matrix completion problem. Matrix completion problem. Okay, that's a beautiful challenging part in the applied mathematics, in applied mathematics topics. Beautiful problem in applied mathematics. Let's see how this actually, how to arrange this thing. See, suppose the matrix that we got from our databases like that. This row is responsible for user I. This row, H row is responsible for user I, and H column is responsible for the item J. Okay, this, and the cell of this matrix are, suppose let's little bit matrix are non-empty. Suppose let's take it's non-empty, somehow here non-empty, somehow here non-empty, somehow here non-empty. A little portions of this matrix are non-empty. Let's say somehow non-empty, somewhere here non-empty. Let's say some little bit, but so but the challenge, the most of the value are zeros here. Challenging very most of the value was empty, most of the data. Like that means I'm talking about like that. So the mist is, so some values of fi are given non-empty, some values of aij means I'm talking about aij means this element, such kind of elements is aij I'm talking about. Okay, some values of aij are given, let, and many of aij's are, many of aij's are empty cells, are empty. If these situations happen, so the matrix competitions problem is, now the problem and competition problem is matrix competition. Now the matrix competition problem. Okay, I'm very weak in English. So if I am doing some misplay here, please correct in yours. Okay. So the matrix competition problem is the fill up the matrix. Fill up. We have to fill up this the empty cells of the matrix A. Empty cells. We have to fill up these empty cells. These are the empty cells. These are the empty cells. We have to fill up by using some value. Fill up the empty cells with some reasonable values. Okay, with some reasonable values. Values based on these the reasonable values that we have to use to fill this matrix. These value must be based on not a arbitrary value. These must be based on the values of based on the values of what in the values based on the values in the non-empty cells. This value must be a non-empty cell. Okay, we have to fill these empty cells by simply using the non-empty cells value of the non-empty cells. Okay, just that the job actually we have to do. So now based on this some reasonable value, we can, if we got some higher value, then we can simply recommended this item or this video or this product to the user correspond respective users. Okay, so this is the, if we somehow solve this problem, then our job is done. Now the questions is how to solve this problem. Now the questions is how to solve this problem. Okay, suppose so to solve this problem, we will see this thing in next video. But let by sample using this value, somehow if we somehow solve this problem, then by using this value, how we will give the output of that problem. Let's see. Suppose this is our the matrix A. This is the matrix size n cross m size matrix. This row is responsible for the general user UI, and this column is responsible for a general item ij. Okay, this item is, so these are the some value that we have to find. These are the some values, these are the values ij. Okay, suppose let's take this the user that give the, actually this is the values, these are the users. Suppose let for this user, for these users they have some. Suppose let the users have given this first movie rating somehow 3. Some the next rating they have given, suppose let's take 2. They have some empty cells. Also they have some empty cells. Now let's take somehow here they have given some rating 5. Now the question is how to find this empty value, how to find this empty cells value, how to find this empty cells value, how to find this empty cells value, how to find it. Suppose let's take somehow using some mathematical hacks, some beautiful mathematical tricks, we will somehow find this value. Suppose let's take we will find this value as a 4.5. Suppose let's take we will somehow find this value 2. Somehow we will find this value suppose let's 3. Since I'm talking about out of, this matrix is actually represented by out of 5. Out of 5. 1 to 5 I'm talking about. It's a discrete matrix, actually discrete. rating is actually represented the discrete value, and if we apply somehow recommend means regression problem, then we got this value. If we got this predicted, this value are actually called the predicted value. These value are actually called the predicted or field value. Field value means we have to reasonable values that we have to filled up. That's the value we have to fill up. Okay, these are the predicted value or field value. Field value. Okay, this value I'm talking about, this same value, field value. And the field value already we have seen. The field value we have been generally denoted in machine learning AI hat. AI, the predicted or field value, by simply using these hat symbols, we will denote it. So here this hat value will be 4.5. Okay, so if we got this, a field value, if we get this field value, this predicted value, means I'm talking about AI hat, ij is I, then we recommended it, recommend we recommend it, otherwise else we have not, recommended it. Okay, that's the job actually. Based on this predicted value, we have to doing this job. Okay, I think you got the idea, you got the concept behind it. Now in next video, we'll see how to predict this value by simple using the features transformation, how to convert this edge vector to a features vector by simply using this matrix, and how to predict this value by simply using this matrix completion problem. We'll see these things in the next video. I think on these discussions, this is a so huge, large discussions. I think you got the idea how this matrix representations works behind this recommendation system and how these things are actually useful in our daily life. I think you got the idea from these discussions. I request you, please, if you have any problem, please comment below or mail me. I will try to give the discussions as simple as possible as I can. So we'll see this. We will see the in our next discussions. We'll see how to improve these things and how to solve this kind of problems. So we'll see in next lecture.